Thank you for joining us again on another episode of the Command Journey podcast. I am your host, Michael Diamond, back with a fresh guest and a fresh perspective for 2024. And I would like to welcome our guest to the show, and I'll do it as we always do. And that is to have the guest introduce themselves. So, guest, please take it away.
Hi, Doug Dreher, uh, member of a Fortune 50 company. Been doing this for about 40 years. So been around a while, seen a lot of stuff, and did about 30 years with the military, another 8 years as a civil servant, working in the realm of physical security and anti-terrorism and some other stuff. Love to bring my perspective, and thank you very much for asking me to join the podcast.
Yeah, absolutely. I think the CV list is a treasure trove of potential perspectives, and we're looking forward to digging in with you today on a couple of questions. So we have had a range of topics over the past year or so on the show, but one of the things that we have been looking for is an individual like yourself that can hone in directly on sort of the higher security, the layered security perspective when it comes to corporate executives or perhaps governmental staffing and employees. And I think that perspective is now critical more than ever, as we'll get to critical infrastructure later in the show, but personnel are part of that infrastructure in a way, and securing them and creating a proper approach within the industry to making sure they have their needs met and also the sites that they visit have their needs met is something I think we get a chance to talk to today. So I wanted to start the conversation with really what makes C-suite level high security locations, what makes them what they are. How do they differ from a corporate setup that is, say, a manufacturing plant, even if it's high volume, big manufacturing? How does it differ?
Yeah, great question too. And we'll start with what's the risk? What's the threat? You mentioned personnel as critical infrastructure. They are. Number one, they are critical infrastructure, not only to the operation, but to the knowledge base of whatever that company is, whatever that organization is. Starting at the top, though, you need to understand what are the threats. And to do that, you need a pretty solid fusion cell for intelligence and where that's coming from. And then not just somebody who can grab that intelligence, you need a generalist. And there are specialists out there in C-suite, executive protection right now, that can help analyze that and say, hey, here's what we see. What we're seeing is this is threat A, this is threat B, this is threat C. And then you build, well, you said those layers of defense around that. Let's talk about the office space first.
Sure.
In their office space, nobody gains access until they go through an intercom. That's a given. The only people that should have access to that C-suite area would be executive assistants, because they're in and out all the time, and the C-suite members themselves. If it's an SVP or a VP, again, this is based on your threat, but the highest security levels would say you're not getting in until we buzz you in. Your badge doesn't give you access, but you can certainly do that if you have the correct access control pieces. And you can tie that in with the intercom system as well. So that's that outer layer of defense in the building. The outer layer of defense starts on the outside. What am I protecting against? If this is a true threat, it's got to start at the perimeter. Do you have fencing? What kind of fencing do you have? And you just roll down that litany through those layers. What are the access controls at my gate to get a vehicle in? How close am I allowing vehicles to park? In some areas of the world, and I've done this, we keep parking way out because we're concerned about vehicle-borne improvised explosive devices, the car bomb, or even a PBIED, a personnel-borne. It's a backpack bomb. Is it a satchel type charge where they can just toss it over the fence? You need to understand what that threat is, what their motivations are, and what their capabilities are. That's what I'm saying. And that helps you build that layered defense. You want them to be, once you get to that C suite, you should be 6 or 7 layers deep. They've already had to overcome 6 or 7 hurdles or obstacles to get to that level at that C suite.
Sure.
And I vary it. I will change up what we're doing. The access control devices, it may be biometric here. It may be a keypad with a badge at a 128 AES encryption.
Okay, that makes sense. I think I harken back to a movie from the '90s, starring Robert Redford called Sneakers, where they're looking over a building, a very secure building, and it looks like a simple toy manufacturing plant. And his sort of keen security experienced eye says, the whole building says, go away.
Yeah.
That could be relevant in a lot of different use cases nowadays, right? To get that idea where if someone wants to threaten the building, wants to threaten the personnel within the building, they need to get the feeling intimately, if necessary, that the building does not want you there,
Yes.
neither do the people inside. I guess I wonder then, when we talk about that sort of same security, if we're talking about securing a location that maybe is a gas pipeline or is electrical farm in the middle of Kansas where there aren't necessarily all of the infrastructure pieces, how does that change your format and fit?
It doesn't. It's just the outer layer of the onion is harder. You need to project that what you referred to as this says go away. What I would consider, let's take the Kansas with the electrical. It's a large electrical substation. What do I do with that? Well, the first thing I'm going to do is I'm not going to use chain link fence. I'm going to use a 9 foot reinforced masonry wall with barbed wire outriggers and possibly razor wire across the top. So effectively, I have a 10.5 foot wall that you have to scale. But more importantly, and we've seen this in the last couple of years, what I call the shooting scoots, North Carolina, Washington, California, where we've had substations taken out and tens of thousands of people without power for days. You're providing a ballistics protection. But more importantly, you do the exact same thing to your manufacturing location too. If you want it to say go away, you can make it say go away. And it could be as simple. I've talked to operators, tier 2 level operators, and that who, if they are looking at a target similar to your call out with Redford, I'm looking at a target and I see a double fence line, an inner and outer perimeter, I'm going to go find someplace else. Because quite frankly, I can see camera poles and light poles, but what don't I see? And that's the key. I don't know what's in that clear zone. That little bit right there can harden you. The other pieces, and I've done this before, set up a chicane, a slalom when your vehicles are driving up. You want to screw with somebody who's pulling surveillance? One day, go out and reverse the chicane, move the blocks to the opposite side. That simple gesture, that action, I'll say, can totally screw up a surveillance plan. So even little things like that, as long as you have to, and this was my training, you have to sit back, kind of like Redford as the bad actor, and say, what's my goal and how can I get accomplished? Anything that messes that plan up, you're doing your job because you're mitigating.
Yeah, it's interesting. Some of the examples that you mentioned, I have seen at larger Fortune 100, Fortune 50 corporate infrastructures where the pathway to the quote front door is not only a myriad of security checks, but even the road, if you're allowed to drive anywhere near the building, is in no way allows a straight direct line for you to drive down. There are turns, there are different ways. And it wasn't to slow a vehicle down, it was to put you in front of other cameras to see the entirety of the vehicle as you approach. So I wonder, Doug, if you could give us maybe a couple of examples with the names protected, but give us some examples of some of the other locations that you've had a chance to do security for.
Oh, yeah, sure. Did extensive operations in the Middle East, across the Middle East, different countries. And one of the really cool things was I had a company who wanted to bring in building materials for a customer, and it needed to be secured. And I said, okay, let's go look at this location. And it's basically a giant asphalt, 150 meter by 150 meter asphalt square right next to a quay wall and a port. And they said, well, how are you going to secure this? I said, give me a day. We'll meet tomorrow. Let me get some measurements and stuff like that. And what we designed for them was a completely portable solution. And by portable, I mean all you needed was a ratchet set and a 6K forklift. And what we did was we built King Tut blocks, so 5,000-pound concrete blocks, put post holes in the top, used panelized fencing. So now I've got a 3-foot tall King Tut block and a 6-foot tall fabric of fence. And we added dual outriggers and razor wire. So now I've got a 10-foot tall fence where the panels interlocked. We designed a figure-8 clamp where all the bolts were on the inside. You couldn't get to a bolt from reaching through. And then we added lights onto those, cameras onto those. We added an entry control point with a barrier arm. We didn't have the luxury of ordering, this newer stuff we see now, lockable, M50 P1 rated barrier arms and that. We had to build the barrier arm. This was back in the day. We used 8-inch steel pipe filled with concrete and then lead weights to counter it. And we could counteract it literally with a finger. It was, and it had an H frame, so you could lock pin it in, kind of like what we see mechanically and electronically today. That was one where we started on the outside and worked our way in. That would be one example. The next example, let's talk about a manufacturing plant where we said this road is 3/4 of a mile long and it's a straight shot. What this plant was manufacturing was part of critical infrastructure. Therefore, we had to apply critical infrastructure rules to them and explain that to them and said, look, your roadway, we need to build a chicane. So we designed that slalom for the vehicles. We're going to slow everybody down. I don't care if it's a tractor trailer or if it's a Jim Bob coming in his Hyundai Elantra, whatever. From that small to that large, we designed the chicane. That's a large construction project. So you need permitting, you need AHJ approval. Went to the AHJ and they said, well, we don't like the temporary nature of the chicane. We explained to them the thought process behind it. They wanted a permanent chicane. I said, okay, we can do that, but realize we're taking everything down to one lane and then we need traffic control devices. And they said, our traffic study, this was the AHJ came back and said, their traffic study says that shouldn't be an issue because it was such a low traffic volume. I said, what about shift changes and stuff like that? They said, it's still such a low traffic volume. We can prioritize inbound before the shift change and outbound after the shift change. I said, you guys are great. That's why you're the traffic study scientist people. And went back to the drawing board, designed a permanent chicane with rock wall and nice plants to fill it in that, way heavier. I think it came into about 12,000 pounds was the estimate for each of these giant walls. And it created the slalom going in and the slalom coming out. It's, again, we're looking at part and parcel to a critical infrastructure bill. These are key pieces that are required to run things like substations and dams and things like that. We can't have a supply chain mishap. They had an outer perimeter fence, standard chain link fence, no outriggers. When we went to permitting and that with AHJ said we want to go, minimum 15 feet inside to create an inner perimeter. I want to use outriggers. Am I allowed to use razor wire? They didn't like the razor wire, but if you give me twin outriggers, that's triple strand barbed wire on both of those fences, it's a fence. When you look at it, it's that immediate deterrent that you talked about. It says go away. The other piece is, okay, if you want to scale it, a fence is a delay mechanism. It gives me delay. It causes you delay and gives me detection. So with those double outriggers and adding another fence, you're at least doubling or tripling your detention time. Simply the fact of going over the barbed wire. If they're doing surveillance or if they're planning, now they got to replan.
Right. And barbed wire is a solution that's been around for hundreds of years, but it continues to be used.
Oh, yeah.
And it wouldn't be used if it didn't work.
Yeah. The same thing is nowadays, we would call them drainage ditches.
Hmm.
If you and I've done that before too, where I built a masonry brick wall and it was in a monsoonal area of the world. And they said, well, we're going to need drainage. I said, put that meter wide, meter deep drainage ditch right at the base of my wall. Let's build it into the foundation of the wall. They were like, but that's going to be a 13, a 3.5 meter drop. And I was like, yes, it will be. But guess what? From the outside, you can't tell that.
Yeah. It's like a castle moat.
And I was getting to. Moats are effective and we still use them.
Yeah. So it's interesting, right? There's a lot of talk here initially about the physical nature and preventing physical movement, restricting physical movement for the ability to slow, understand, detect, identify. It leads me to the next portion of the discussion, which is what if we flatten everything down to the IP and we talk about digital incursion and how to harden and cyber secure locations? It's a huge conversation. But I wonder when we look back to something that is C-suite level, executive, senior VP, et cetera, what sort of steps are you seeing in the market? What sort of steps and setup are you taking to secure those positions?
Oh, sure. And you're right. That's a whole show. But to get down to the point, what started that out? Let's start with our layers. Your access control systems. And for the security-minded folks on here, I'm going to ask the question: are you still vegan? Have you moved to OSDP? What about your badge stock? Have you moved to a badge stock that incorporates an NXT chip? The latest one is EV3 of the NXT's badge. And the reason I ask that, if you are using the communications protocol within your access control system as OSDP version 2.0 or higher, you're running AES 128 encryption. For a cyber attack, yeah, good luck. Not going to happen unless you got 35,000 spare years to sit around and wait. The other piece is the badge. We know that badges have been cloned before. We know social engineering works with the cybersecurity community, and we know that it can actually be effective. The key is if you move to the NXT, like an EV2 or an EV3 chip inside that badge, that's also AES 128, which means you're not going to be able to clone it. You're not going to be able to get the information you need out of that badge. Is there a PIN? What's the facility code? Things like that. That would be the first layer in cybersecurity. When it comes to critical infrastructure, the second layer, and I'll tell you, this is one that is overlooked the most, SCADA.
Hmm.
Are you protecting your control systems? What does your network look like? What is your local area network? Or do you have a LAN? Are you running things off of Wi-Fi? Do you understand that we can pick stuff up off of Wi-Fi? That we can hack it? Now, there are solutions for that. There's companies out there that make what they call wireless fiber. I've tested a couple of them in a semi-live environment. I can tell you this. When we test it in semi-live, being it's not a manufacturing production environment or anything like that, but real test, real data going across. There's one that I found that, I had a fluke and I couldn't even detect it was there
Mm.
at the first 300 meters. After that, the light form starts to go out, the laser starts to spread out, so you can kind of pick up stuff. But what's your encryption on that? Your switches. People overlook this all the time. I'm going to take a camera and I'm going to plug it into the switch. Okay. I have an RSTP stream that's going from that camera into that switch. Do you have security on the switch? If you're telling me no, it's a dumb switch, then my first question is going to be, what are you doing? You need to look at the BIOS, use port security where you can, lock it down to MAC address where you can. Look at your purchasing. Am I buying the right equipment? So that goes back to this SCADA piece, because let's just talk about 2 weeks ago. Was it 2 weeks ago now? With the director of the FBI
Yeah, something like that.
in front of the Intelligence Committee. So look, we know they've hacked our stuff. And if that's the case, what is your plan to go back and fix that? Because you've got to have a plan. This should be a red flag for everybody. And I'm telling you, when it comes to critical infrastructure, you don't want to be that group. Knock on wood. I don't want anybody to be that group, quite frankly. I don't want it to happen, but you've got to, again, there are layers in cybersecurity, just like there are in hardened physical security. Are you setting that outside layer so that if Robert Redford does show up looking at a computer screen next to Neo or whoever's trying to hack you, he goes, yeah, we're not going to go in there. That's not going to be a good idea. You want it to be so difficult for them that they just go away. They're going to look for a softer target. So I think that's going beyond the basics. Those are some of the basics, but going beyond that, encryption, 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 encryption. There's future with that as well.
Yeah, I look forward to the fascinating developments in encryption because it's such a changing field, and because I think that encryption ultimately is one of the things that can lead to a safer future. It's just going to be something that people are going to have to not get over because that's the wrong mentality, but just learn to live with. That certain parts of it are about safety. We did that at airports after 9/11. We had to accept that there were a raise in security levels. And listen, nobody liked taking their shoes off. Nobody liked missing out on seeing loved ones until the gate and all that. But when and situations happen, world events change things, we have to be flexible enough to realize that we can't be exposed like that again. And I hope that we're never exposed to stuff like that ever again. But it does keep those moments in mind when you're sitting at your manufacturing facility, you're out there, and the budget for this year and next year are on the table, and people are saying, what do we need to do? It's important that dealers and integrators are out there in their customers' ears saying, it's not just the gate, it's not just the man door, it's not just the camera system you want to look at. We have to look at all facets. What does that all run on? And is that protected? Is that secure? Because I can put up the coolest camera that money can buy, but if it's not on a secure network, I don't own that camera.
Nope, you sure don't. Access control systems, the exact same thing. I mean, mobile key technology is cool. I can gain access via my phone. Okay, I'm going to ask you what your security protocols are.
Right.
You hit that nail dead on the head.
So usually as the wrap up question I'd like to do is I like to look forward. I enjoy looking forward because not because I find it exciting, but because everybody's perspective on the future is different. So if we scan forward 5 years, what's the topic we're talking about if we're back at this table?
Wow, that's a good question. And my answer is going to be quantum and AI. And the reason I say that is quantum computing is infancy right now. The results we're seeing from quantum computing sites that are published are wow. You know, uh, one quantum computing site gives it a problem that the estimate from a Cray waterfall. So a supercomputer says this is going to take me 9,785 years to complete, and the quantum computer completes it in 45 minutes.
Right.
What does that do to our industry? You said encryption schemes. What does that do to encryption schemes? We are going beyond AES 128 and beyond 256. You're going into a whole different realm because we're not talking a serial calculation. You're talking multiple calculations simultaneously. I think that gives us a more secure future. I know a lot of people in the audience are worried about artificial intelligence. What is that going to do? The answer is we really don't know, except in the security industry. I can tell you in our industry, when we're looking and I'm actively looking at artificial intelligence and deploying it, there are some really good AIs out there right now that are truly AIs. Sub neural network kind of, they learn on their own. But the cool part about security, they're locked into a camera view. So we have guardrails. But what happens when we step outside of those guardrails? Then we're in the same realm as everybody else. I've
Mm.
seen announcements through Wall Street Journal, Forbes, and places like that over the last week where the Department of State for the US has said you will stand up an artificial intelligence. The DoD's already had one with Cybercom. I guarantee the agencies, even though I don't know this for sure, I can guarantee they have them. What a lot of your Fortune 50, 100 companies are already knees deep in this. We've seen the letter from the CEOs to the US government saying you need to put up guardrails. You need to slow down. And when the grandfather of AI says, time out, we're moving too quick,
Right.
that gets everybody up in arms. And I'm with you. I think the future is very bright. I think it's more secure. What worries me are the dark web stuff because we've already seen, everybody knows Chat GPT, and we know it exists on the dark web. We know that it's been used to write malware. As it increases on the light side, it's going to increase on the dark side. So how do you counter that? Well, it's job security for us, if you think about it that way,
Sure.
because we're going to be the ones in the security industry who are going to have to say, wow, they used an AI voice and I'm using voice recognition through an intercom system and it let them in the door.
Hmm.
Those are things we have to think about. If you're using voice recognition, that's gone. I've actually listened to some of the AI voice recognition stuff and you can't tell the difference. Can a computer, can an algorithm possibly? This is where quantum computing can help us out because it can evaluate 50,000 different things simultaneously. And it can identify those glitches that maybe a system today can't, and certainly the human ear can.
Yeah, and there's the potential layers there too, right? You could induce a two-factor authentication system in a voice required environment.
Yeah,
And so while an AI trained voice might be able to get past the voice print, it can't produce the second factor and so it can't get in.
exactly.
It's an exciting time in the industry because there are going to be things that we can't see yet, and that's why I love this question, and the perspective is great. Well, that's the final question I have for you, Doug. I'd like to thank our mutual friend John Keltner for helping us link up. So thank you, John. I appreciate you coming on the show and joining us for the command journey. It's always an interesting time talking to someone with your deep background, and I'm certain will spark some questions. So thank you very much.
Oh, you are welcome and happy to come back anytime you want.
Certainly, I will take you up on that.